Hello and welcome to our lesson on inverse functions. Today our goal is for given a function, find its inverse and determine whether the inverse is a function. Now inverses work the opposite way as functions. So if you think about, if we know the diameter of the pizza, we can figure out what the price of it is. Now sometimes we'll have the price that we're willing to spend on a pizza, and we want to find out what the diameter is that we can afford. So in that case, we'll be looking at the inverse. And this is how we write inverse, f to the negative 1 power. Now, as x uses f to get to f of x uses f inverse to return back to the original x. So in the previous situation, what does f of 10 equals 12.5 mean? It means a 10-inch pizza will cost $12.50. Now f inverse of 15.75 equals 14 means $15.75 can buy a 14-inch pizza. All right. Now, an invertible function is a function whose inverse is also a function. To do this, they have to pass a horizontal line test. The original function does. Now, you're used to a vertical line test for finding out if a relation is a function. To figure out if a function is invertible, we do a horizontal line test. And it's a function if there's a one-to-one relationship between the x and y. So for each x, there's one y, and for each y, there's only one x. Now, if we look at these tables, one is an example of an invertible function because for every x, there's one y value, and each of them are separate. And for each y, there's one x. For b, if we look, 4 goes to 9, and 6 goes to 9, so that is not invertible. If we look at c, we have 1, 3, 2, 5, 3, 7, 4, 9, 5, 11, but we go back to 4, 9. This one would still be invertible because 4, 9 and 4, 9, it doesn't mean we're using it twice because the same x gives us the same y value. Now for this one, 9, negative 3, and 9, 3 would tell us that it's not a function because we have an x value that goes to two different y values. All right, if we wanted to find the perimeter of a square, we would take p equals 4l, 4 times the length. Now if I put it in f of 3, that answer would be 4 times 3, which is 12. What that means is if one side length is 3, the perimeter is 12. F inverse of 20 tells us if the perimeter is 20, what is the side length? Well, we take that value, divide it by 4, and it would be 5. Now if I put it in a p, what I had to find the length, what I would have to do would be divide that p by 4. So this would be the formula for all of the values for F inverse. We can do the same with the cost of producing air conditioners. If I put in a 30 for x, I'll have 600 plus 45 times 30. I should pull out my calculator. 600. Let's try it again. Maybe it's going to take my calculator a little bit. Maybe I should just do it by hand. 45 times 30 is going to be 1,350. Add 600 to it, and it's 1,850. Now, if I have F inverse of 2,850, what I do is that's going to be my cost. And now I subtract by 600, so 2250 is equal to 45x. Divide by 45 on both sides, and x is going to be, I believe that's 50. All right, now F inverse of c, now we're looking for the equation. what did we do here? First we subtracted 600 and then we divided by 45. So I'm going to take my C, I'm going to minus 600 from that, and then I'm going to divide by 45. All right, so let's look at graphs. F of 0 from this table is going to be 2. F of 2 is going to be negative 3. But now if I want to find F inverse of 0, now I'm looking at the y's and I want to find out the x. So F inverse of 0 is 1. F inverse of 2 is 0. Now if I plot these graphs, negative 2, 5, negative 1, 4, 0, 2, 1, 0, and 2, negative 3, I can connect these dots to form a graph. Now to graph the inverse, I flip the x and the y's around. So instead of having the point negative 2, 5, I have the point 5, negative 2, or 4, negative 1, 2, 0, 0, 1, or negative, and negative 3, 2. So now I'll put those points on. And if I connect those, now hopefully what you see is there's a symmetry here, which is a reflection over the y equals x line. So they just flip over that y equals x line. Now, these we've already done. So the graph of f inverse of x is just a reflection over the y equals x line. All right, so now when we graph the inverse of this function, if we don't know what this point is, but let's say it's negative 5, 0. That will give us a point of 0, negative 5. Say if this is negative 3, 4, we would go 4, negative 3, and make a dot. 0, 1, 1, 0. 3, 1, 1, 3. And 0, or 6, 0, 0, 6. And of course, right now it's just a rough sketch. But that's roughly what it looks like. Now if we take a look at drawing a line through the y equals x, does that look roughly like a reflection? Looks close enough. All right. Now if we want to find the equation for the inverse, our first step is to switch the x and the y's. So x is equal to 4 y inverse minus 5. Now we add 5 to both sides, so we have x plus 5 is equal to 4 y inverse. Now we divide by 4, so x plus 5 over 4 is equal to y inverse. So that's our function for, now it says for find f inverse. We could also say this is f inverse of x is equal to x plus 5 over 4. I think it's a little bit easier to work with a y inverse in the problem than an f inverse of x. All right, so if I were you, I would pause this and then do it yourself. All right, so I would change the x and the y. So I'd subtract 1 on both sides. So I have x minus 1 equals 9 y inverse squared. Divide by 9, and I have x minus 1 over 9 equals y inverse squared. The opposite of squaring is a square root, and whenever you square root, we need to do a positive and negative. X minus 1 over 9 will be my y inverse. One more step, we don't like having square roots in the denominator, so we can do plus or minus the square root of x minus 1 over 3. All right. Now this is a tricky one. So y equals x plus 2 over 3x minus 4. Switch your x's and y's. Now what we're going to, since we have this in the numerator and denominator, we're going to want to multiply both sides by 3y inverse minus 4. 3y inverse minus 4. That'll cancel out on the right-hand side, and I'll have 3y inverse minus 4x equals y inverse plus 2. Now I multiply that x over the parentheses, so 3x y inverse minus 4x equals y inverse plus 2. Put the y inverses on one side, everything else on the other. So I'd subtract y inverse, add 4x, subtract y inverse. So I have 3x y inverse minus y inverse equals 2 plus 4x. Now we want to isolate this y inverse, so I take y inverse to the outside, and I'm left with 3x minus 1 equals 2 plus 4x. Now I can divide both sides by 3x minus 1, and I have y inverse is equal to 2 plus 4x over 3x minus 1. All right. Now, if we take a function like f of x equals 4x plus 3, let's look for the inverse. The inverse is going to be x equals 4, y inverse plus 3. Subtract 3. Now we divide by 4, so x minus 3 over 4 is the inverse. All right, so let's see what f of f inverse of x is. So if I take f inverse, so that's going to be f of x minus 3 over 4. If I put that into this equation, I'll have 4x minus 3. That's supposed to be a 3 over 4 plus 3. If you multiply 4 into this equation and then divide by 4, really those two just cancel out. So I have x minus 3 plus 3, which brings me back to x. So the composition f of f inverse of the function is always just going to be that x value. All right, so f inverse of x is x. F inverse of f of x is also x. All right, you can actually do all of the worksheets that I hand out. All right, good luck.